Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today in our 421st episode, we have a bunch of news, including a dinosaur that looks like it was a very good swimmer, even though Spinosaurus might not have been the best swimmer. This dinosaur seems like it was probably a fantastic swimmer.
There's also a new dromaeosaur with parts of its intestines that were found.
That is crazy.
Yeah. And a pregnant T-Rex on display.
What?
Yeah, we'll get into it. And a T-Rex skull that sold for much less than expected.
Oh, interesting.
Yeah, lots of interesting news items before we wrap up this year, because our next episode, episode 422, very fitting, will be our best of 2022 episode.
So many twos.
Yeah.
And of course, you have dinosaur of the day, Ostafrikasaurus.
Mm-hmm.
Ostafrikasaurus, I'm not sure exactly. And of course, I have a fun fact. But before we get into all of that, we want to thank some of our patrons. And this week, we want to thank McManosaurus, JC, Danny Hermes, Seamus B, Remy Rodriguez, Brad Shelby, TRX Dinosaurs, Stefan, T-Bear, and Ewan.
Yes, thank you so much, everybody, for being a dino-it-all.
Mm-hmm.
We really appreciate all your support.
And yeah, just a quick reminder, we're going to be retiring the Ankylosaurus tier. So if you're interested in joining at that level, make sure to join by the end of the year. You can still join after that and get shout outs by joining at the Triceratops or Tyrannosaurus or Spinosaurus levels.
Yes, and we'll be adding more things to our Triceratops tier.
Coming in 2023.
To a Patreon near you. Specifically ours.
Yep.
Patreon.com/iknowdino. And now jumping into the news. My news item's so cool, I get to start it off.
Yeah, when I was talking about my news item, I was like, it's so cool. I'm obviously going first. And Sabrina was like, no, mine's definitely better. And I think you're right. I'm very interested in hearing about this.
Intestines.
That is crazy.
Yes. So paleontologists, they discovered a new dromaeosaur, Daurlong wangi, and it's complete with part of the intestines.
I don't understand.
Okay, well, they found preserved in the abdomen this large bluish layer, which represents intestinal remnants. And I say intestinal remnants because the stomach wasn't preserved, possibly because the stomach was so acidic, which is too bad. You know how I love gut contents.
That's true. I mean, the intestines are part of the guts. So if there's any contents in there.
That's true.
It doesn't sound like it.
So this was published in Scientific Reports. It's open access, which means you can go to the link in our show notes and see the images.
Nice.
It was published by Shuri Wong and others. And this dromaeosaur, Daurlong, was found in the Johol biota. And it's from the early Cretaceous, around 100 million years ago. It was found in the Pigeon Hill locality in Inner Mongolia in China.
Yeah, we've heard of that spot before.
Yeah. And the Johol biota just has so many cool animals coming out of it.
It does, yeah, especially if you're talking about little bird-like dinosaurs. That's the place to be for sure. And if you want to find a feather. Or, I guess, intestines.
Yeah. They've got it all. Probably. So the genus name Daurlong comes from the Daur Nation and the Chinese word for dragon, long. And the Daur people live in that area. The species name is in honor of Wang Zhenyo, director of the Inner Mongolian Museum of Natural History. The holotype is nearly complete and articulated. It includes, I know, it's pretty much the whole body, including the complete tail. You can see this in the pictures. There's most of the skull, and there's feather remains on the back of the skull and neck and edges of the tail.
Oh, cool. Yeah, the back of the skull is a neat place to have feathers. We see them a lot, like around the body or around the arms/wings, sometimes the legs, but not so much on the head. That's really neat.
Yeah. It's pretty cool, but it doesn't beat the intestinal remnants.
Yeah.
Now, this is a medium-sized dromaeosaur.
Oh, really? I thought it was just going to be a little tiny bird.
No, it's estimated to be about 4.9 feet or 1.5 meters long.
And it's fully articulated and has feathers. It almost sounds too good to be true.
I know. The pictures are amazing. Its jaws are not quite as long or slender as Dromaeosaurus, but It looks fairly similar. It walked on 2 legs, it had the large sickle claws and the long tail, and it was feathered. There's a large scleral ring that's nearly completely preserved inside the orbit where the eye was.
Oh, that's really cool. Yeah, those are the eye bones that some reptiles have and
Yeah.
other animals.
Those are usually hard to find.
They are, but if you can find them, they're really handy because they show you how big the eye was.
That's true. Daurlong also had long, robust teeth, as some of the teeth in the middle were fang-like, similar to microraptor teeth. And it had short arms that were less than 60% the length of its legs.
I mean, I guess that's short. But like, I feel like our arms are in the ballpark of 60% the length of our legs.
That's a good point.
It's not quadrupedal. They're not the same length as the legs, but that's still a decent sized arm.
I guess it depends on which dinosaurs you're talking about.
True. And I guess if we're talking about the J-hole biota with all the birds, right, a lot of them have bigger arms than legs because they have wings. So yeah, good point.
So comparatively. All right, now on to the intestines. Now we've gotten the rest of that description out of the way. So the bluish layer in the back half of the rib cage, it looks really similar to the intestinal tract that's also preserved in Scipionyx. That's a compsognathid that lived in the early Cretaceous in what is now Italy. This bluish layer was formed by densely packed microcrystals, and those may have been from decay bacteria. Now, intestinal tracts, they're rarely found in non-avian theropods.
I didn't realize they had ever been found before.
I didn't either until this paper, yeah. They're thinking that Daurlong probably ate small prey like mammals, fish, small dinosaurs, frogs, salamanders.
Probably the occasional, small mammal. Oh, you said mammals.
The intestinal tract of Daurlong, it helps show more about theropods. So, for example, the authors reinterpreted what used to be considered, we thought were eggs in the abdomen of a Sinosauropteryx specimen as intestinal remnants.
Interesting.
Yeah, that's based on them closely matching the shape and position of the Scipionyx intestine and part of the bluish layer in Daurlong. So comparing these two that we know are intestinal remnants to what we used to think were eggs, now they think is also intestinal remnants.
That's really surprising because eggs to me look nothing like intestines. But I guess if you just have a tiny piece of intestine and a tiny piece of egg, they're in the same general part of the body, so you could make that mistake.
It also makes sense because that Sinosauropteryx specimen is considered to be skeletally immature. So, yeah.
Makes sense that it wouldn't have an egg.
Yeah, exactly.
Well, that's really cool. I want to hear a lot more about this dinosaur.
I'm sure they're going to do future studies. There's, of course, the feathers to look at, too.
And it's so big for it to be fully articulated with a complete skeleton and the sclerotic ring and everything for, a 5-foot-long dinosaur. That's super similar, what did you say, to dromaeosaurus? That's awesome.
Well, it's a dromaeosaur, so to me it looked similar to Dromaeosaurus.
Well, yeah. All right, now on to the dinosaur which probably could swim very well. This was published in Communications Biology and written by Sung-Jin Lee and others. Real quick, what do you think is the biggest issue with Spinosaurus swimming?
Well, we've talked about the sail might get in the way. So I guess the shape of the body.
Yes. Did you read ahead? Do you know why they think this was an aquatic dinosaur?
No, I didn't read ahead.
Well done. Okay,
Thank you.
So they think that the lack of a streamlined body on Spinosaurus is basically the biggest problem with it being a good swimmer.
Okay, that's this group of authors because I've seen a lot of debate on social media from other people with other ideas.
Yes, but it is a very fair point when you're talking about Spinosaurus, especially like you said with the sail. Unless they're swimming solely on the surface of the water, which is a very strange thing to do for an animal. I can't think of any aquatic animals that stick to the surface 100% of the time. There are animals like ducks and things that fly and then land on the water. But if they're fully aquatic reptiles, they do a lot of swimming underwater because otherwise how are you going to catch the food?
Yeah. You go where the food is.
Exactly. And it's not right at the surface all the time. There are obviously other problems with Spinosaurus too, like perhaps it was too buoyant. It might not have had enough propulsion, things of that nature, but...
I'm sure this will be further hashed out in future papers.
Yes, but that sail, I think, is the biggest problem. It's literally going from fairly streamlined with something like a baryonyx to much less streamlined by having that huge sail on its back. And that sail does not fold down. It's always important to note because one of the fastest fish in the ocean is the sailfish, but the sailfish can fold down its sail, and it does fold down its sail when it's swimming quickly. So, yeah, Spinosaurus couldn't. Its sail was also way bigger and wider, and anyway, just not great for swimming. This new dinosaur seems to have a very especially streamlined body, like above and beyond even basically anything we've ever seen before in a non-avian dinosaur. Its name is Natovenator polydontus, and Natovenator comes from the Latin nato for swim and the Latin venator or venator for hunter, so it means swimming hunter.
Oh, so you know exactly what they're going for in the name.
It is always a risk throwing your hypothesis about its behavior into the name of the animal, like Oviraptor, which probably didn't actually go after eggs.
Yeah.
But, it seems a little bit better in this case, I think. And then polydontus is Greek for many teeth. And they said, quote, in reference to the unusually many teeth.
Well, that's something that'll probably stick around.
Yes. It's usually safer to base things on actual features of the bones than hypotheses. So this new Natovenator is a Halscaraptorine.
Oh, that's a cool group.
They're really cool. Halscaraptorines, if you're not familiar, look vaguely like an evil swan.
An evil swan.
I would say.
I always think more geese.
Yeah, geese too. So they have sort of a swan-ish neck. Geese also have a fairly long S-shaped neck, and those necks on swans are useful for grabbing fish. They scoot along the surface of the water, and then they can stick their neck down and grab. They can also dive a little bit. But in this case, the Halscaraptorine, they think that it could also use its neck to grab fish. You could also think of like a plesiosaur with a long neck. If you took a swan and added a tail, made the legs longer, and turned the arms into flippers, and then gave it teeth.
Ooh, so very ferocious.
You'd end up with Natovenator. Yeah, except that Natovenator was much smaller than a swan. It was more like the size of a duck.
Oh, don't be fooled by its size.
It's still ferocious, even at the small size.
It could be, yeah.
Yeah, it's true, especially if you're a fish.
Mm-hmm.
So Natovenator was about 30 centimeters or 1 foot long, although about half of that is its tail.
So it is pretty small.
Yeah, it's quite small. And while standing, it was probably about 20 centimeters or 8 to 9 inches tall. So yeah, this is a small bird. Or non-avian dinosaur, not a bird. This individual, because again, we don't know what all Natovenator were like, but this Natovenator was about half the size of the Halscaraptor holotype. Halscaraptor already isn't very big, and this is half the size. The Halscaraptor is estimated at about 1 year old and still growing, so I'm not sure if this Natovenator specimen was an adult. I didn't see reference to it anywhere in the paper, or if it was a juvenile or doing any histology. So hopefully in the future, someone cuts open a bone or does something so we can figure out if this is near the maximum size or if it is still growing and that's why it's so tiny. Finishing up a quick recap of Halscaraptorinae, they are named after Halscaraptor, which we covered back in episode 160 when it was found. We've been doing this podcast for a while. We're already at episode 160 by the time they discovered Halscaraptor. Halscaraptorinae is a very new group. It was named in 2017 with Halscaraptor.
Makes sense to be named with Halscaraptor.
Yeah, it'd be weird if Halscaraptorinae came way before Halscaraptor. And this is just your weekly reminder that we're in the golden age of dinosaurs.
So many discoveries.
Yes. The group and also the genus Halscaraptor are named after Halska Osmolska, who is a paleontologist who first described a Halscaraptorine, although at the time she called it a dromaeosaurid, since the group wasn't defined for another 35 years. And in her defense, Halscaraptorines are dromaeosaurs or raptors, so she wasn't wrong, she just didn't have any other ones to group it with into this new subset.
It's just making it more specific.
Yes. When we found Halscaraptor in 2017, it changed pretty much everything that we thought about these types of dinosaurs, especially because we had a nearly complete skeleton, which was not true for that early Halscaraptorine that was found. It includes sickle claws, which confirmed that Huscaraptorines are, in fact, a subset of raptors. In fact, Huscaraptor had 2 complete sets of legs, nearly complete arms, a great skull, and most of the vertebrae.
It's a good specimen.
Yeah, it was really cool. And the arm showed that it may have used its arms as flippers.
Mm-hmm.
They're very flipper-like, or they had some flipper-like tendencies. It was missing some bones that turned out to be really important to the aquatic debate, which were the ends of the hips and the ribs. Doesn't seem like the most important thing, because usually you're thinking, okay, well, what kind of tail did it have? What kind of legs and arms did it have?
Mm-hmm.
But those are the bones that outline the depth of the chest and just the torso in general, and therefore how streamlined the body is.
Okay.
So a lot of people were saying, well, we can't really say that Huscaraptor was aquatic because we have no idea how big its body was. And if it had a really deep body, it probably wasn't swimming.
So I think that going back to the Spinosaurus debate, that's some of the points that have been made is, well, there are still some missing bones, some pieces of the body that we don't know yet that could answer the question better.
Absolutely. Yeah. When we talked about it last week, the difference between the paper that said it was aquatic versus it wasn't, they had a very different size of torso going on. I think one was like a third smaller than the other. And that really affects things like the balance and how streamlined it is. Although everybody kind of agrees it has a huge sail on its back, which isn't great for the streamlining.
Right.
So back to Natovenator. It was found in Mongolia, just like every single other Huscaraptorine. Specifically, this one was found in the Burungoyat Formation. That's about 72 to 71 million years ago. It's possibly a couple million years after Huscaraptor because it's one formation up. Like many Mongolian fossils, it's in really great shape. It's another really beautiful find. It's not in as good of a shape, obviously, as the dinosaur you were just talking about with the intestines.
There's no intestines here.
There aren't. And it's not nearly as complete either. And it's also not fully articulated. But it does have a skull, and the skull has very long, thin jaws packed with teeth. It also has huge eyes that look to be even bigger than Huscaraptor, at least proportionally to the skull. Maybe not overall, since it's a smaller dinosaur.
Right.
That's another common aquatic adaptation. Since there's less light underwater, a lot of times aquatic things have big eyes. Like you think of giant squid and things that in 20,000 Leagues Under the Sea, it's like a giant eyeball comes up next to the submarine.
Yeah.
Like they actually do have really big eyes, a lot of these animals underwater. The nostrils on Natovenator are also higher and farther back on the head. Think of like a blowhole on a whale. That's another common adaptation. And in that partially articulated skeleton, they have the hand and base of the arm together. They also have the skull bones mostly still together, and they have several vertebrae which are still lined up as they were when it was alive.
Nice. That helps.
It does. And even better, for once, the most important bones, the ribs, are also semi-articulated with those vertebrae.
Cool.
The ribs are articulated in a way where they're pointed more towards the tail than in other dinosaurs.
Is that part of the streamlining?
Exactly, yeah. So in most dinosaurs, the ribs point down towards the feet, which give it a deeper chest. But in Natovenator, the ribs point more towards the back, which give it a narrow and long rib cavity. So if you think like the very bottom or back, like towards the tail ribs are pointed back to, so the lungs would have been farther like stretched lengthwise. It's not like they were just smaller lungs and more compressed up. They're like lengthened out, as is good to do. That's how you get that streamlining sort of stretch. And that probably wouldn't serve much of a purpose on land, since dinosaurs don't run fast enough to encounter much air resistance. But if you're in the water, the resistance happens at a much lower speed, so that streamlining is much more important. It also doesn't have limbs that look like it was for burrowing and going for a long weasel shape. I had to check that. They didn't talk about it in the paper, but other animals that lengthen are some things that burrow, because it's the same sort of like streamlining through dirt. It's even more important than streamlining to get through water.
I never thought about that because, well, I guess meerkats are pretty long. I always think, though, of burrowing animals is small because they got to fit into this small burrow.
Yeah, they are small, but they also tend to be long and skinny. Like if you think of worms or like a lot of these things that are underground, because you don't want to be pushing tons of extra dirt out of the way. There are some animals that burrow, like cave bears and like weird things that are enormous and not very streamlined that go underground. But for the most part, things that are underground tend to be a little bit narrower. There's one obvious question, which is, what if the ribs just shifted during fossilization, but they were pointed down towards the feet like a typical dinosaur when it was alive, and then they just sort of got shoved back while it was fossilizing? Fortunately, there's another piece of evidence for a streamlined body in the ribs. The ribs themselves are also arched up around the vertebrae, making them more streamlined. So as they put it, quote, this barrel-shaped rib cage is also known in putative semi-aquatic vertebrates, including spinosaurids. End quote.
Oh, interesting.
Very interesting that they're talking about a streamlined dinosaur and then comparing the rib cage to spinosaurids.
Yeah.
I don't know why they wanted to open that can of worms, but they did.
Because why not? Future research.
Yeah. The vertebrae also have projections that look similar to those on Hesperornis, which I believe is universally considered aquatic. Hesperornis, if you're not familiar, is considered to be a bird. It's not a non-avian dinosaur like the Halscaraptorines. It's an avian dinosaur.
But it's got teeth.
It does. And it's basically like a big penguin-looking thing, except its legs worked in a different way. And it wasn't really that penguin-y, but that's the closest thing we have today to Hesperornis. It was also around, I think, about 10 to 20 million years before Natovenator. So Natovenator doesn't have the title as the first fully aquatic or nearly fully aquatic dinosaur because Hesperornis definitely beat it to the punch. Although it might be the first non-avian, yada, yada, yada.
Sure. Or could it just have the title of a very aquatic dinosaur?
Yes, I think so. To that point, the teeth are longer in the front of its mouth than in the back of the mouth. Presumably that's for it being better at snagging fish, sort of like a spear. You want the points at the end of the spear, not at the base of it. And although none of the teeth are particularly long, all of them are in the order of millimeters, it is noticeable that those front teeth are longer. Based on the rock, we know that Mongolia in the late Cretaceous was mostly arid to semi-arid. We've talked about that before, how Mongolia today really isn't that different than Mongolia was in the late Cretaceous. It was a pretty dry place, and we find almost everything in sandstone there. So it seems pretty weird to find a swimming dinosaur in a place that's largely desert now.
Yeah.
But there were, just like today, there were rivers and lakes, although some of them were temporary. So Natovenator was presumably swimming in rivers and lakes and not in the ocean.
Freshwater.
Yeah. And it didn't have wings. It had short arms that might have worked like flippers. So it couldn't fly between bodies of water, but it did have long legs, so it could always walk or run from stream to stream, I guess, when it was looking for some food. Or if one place dried up and it needed to get to a new place, you just run across the land to a new place.
Or maybe it could slide down hills on its belly.
Like a penguin?
Yeah.
I guess, I mean, yeah, sure. The sand dunes, you could do that. I don't know how enjoyable that would be on like a hot sandy dune.
Maybe not. But it's enjoyable to imagine.
Yeah. So there's pretty definitively now a non-avian dinosaur, which was aquatic. You could call it semi-aquatic if you want. We don't really know how aquatic it was.
Also depends on your definition of semi-aquatic.
It does, yeah. Considering turtles today are considered semi-aquatic, I think it's safe to call this dinosaur semi-aquatic, especially with how long its legs were. And it's still a claws.
And now we're going to pause for a quick sponsor break, and when we get back, we'll talk about that pregnant T-Rex.
Oh, yeah. Forgot all about that. That sounds awesome.
All right, Garrett, I know I told you at the beginning of the show we would talk about a pregnant T-Rex, and that's probably true. It's more like it's possible that this T-Rex was pregnant.
Okay.
So this is one of two T-Rex that's on display at the Auckland War Memorial Museum in New Zealand. There's Peter and Barbara. Barbara's the one that was probably pregnant. Kind of interesting, too, that the nicknames might match.
Oh, they didn't nickname it after they found out it was pregnant?
I'm not sure. I'm not sure where the nicknames came from.
Probably not, though. You're right. Usually things get nicknamed based on who discovers it or who buys it or something like that, not based on how pregnant it looked.
Yeah, yeah. So Barbara apparently is one of 3 pregnant T-Rex specimens found and is pretty complete. About 44% of the bones have been found. This is based on a preliminary report. done on both Peter and Barbara by David Burnham and John Nuds. It's unclear if these preliminary reports were peer-reviewed. We actually talked about Peter the T-Rex back in episode 386 when Peter first went on display.
Yeah, I was thinking, did we miss 2 T-Rex dinosaurs when we briefly stopped in New Zealand? But 386 was long after our trip.
It's too bad.
Yeah.
It'd be cool to see them. Now, the reason they're saying possibly pregnant is because there's growth found in bone that may be medullary bone. So I think when we see the phrase pregnant T-Rex, it refers to the medullary bone.
Oh, I see. Okay.
So these other T-Rex specimens with medullary bone, there's the one at the Museum of the Rockies, which we have seen, and there's one at the University of Kansas Natural History Museum.
Okay, so all of those have medullary bone, and therefore they think they might have been pregnant.
Yes.
I feel like pregnant is a weird term for something that lays eggs. Because it's like, are you pregnant if you're laying an egg?
Think about the kiwi.
Yeah.
That the kiwi bird seems very much pregnant when laying an egg.
Because the egg is like half the size of its body.
I think it's a third, and it takes a really long time to grow that egg in its body.
It does. Yeah, I guess you're right. So I guess it depends how big and how many eggs T-Rex had in it, if it counts as pregnant.
So Barbara and Peter, they're both on loan from someone anonymous, and they're both mounted to look like they're hunting. They're going to be on display until the end of the year, and this is the first time ever that Barbara, the specimen, has been on display. In the preliminary reports, they talked about how they CT scanned both specimens. As a quick reminder, Peter was found in the Lance Formation in Wyoming, and Peter's bones are this obsidian black color, like the Black Beauty specimen at the Royal Tyrrell.
Oh, nice.
Yeah, so real pretty. There's also teeth marks found on the bones, and some of the bones have these broken edges, like the leg bone may have been crushed based on that. There's also evidence of tooth marks from a larger animal and a smaller animal, so possibly an adult and a juvenile something. And based on the bone crushing, it could have been from another T-Rex. So it's possible Peter was killed in a fight or was cannibalized. Now, Barbara was found in Montana in the Hell Creek Formation and is about 38 feet or 11, 12-ish meters long.
That's about as big as they get.
Yeah, pretty big. And Barbara's bones are light brown in color. Barbara also had a really bad foot injury. It's unclear how.
Well, based on what you found at SVP, it might have just been because they were so heavy.
That's true. But it did heal. It's possible that Barbara had a limp, and maybe it took like 6 months or longer to heal.
That's tough.
Yeah, so maybe Barbara got some help or needed help getting food. Especially if Barbara was maybe pregnant.
Pregnant, walking with a limp.
Yeah.
You can see how it ended up getting fossilized.
Oh.
Is that too morbid?
Yeah.
It's vulnerable. It's a vulnerable time.
That's true.
That's really cool. Yeah. If you're in New Zealand, I would definitely recommend checking those out before the end of 2023 when they aren't there anymore.
Mm-hmm. Unless they extended. I think they already extended Peter's stay. Now, the other news item I teased at the beginning of the show is that there's a T-Rex skull that's sold for a lot less than expected, also known as Maximus. Now, Maximus, the skull was found in Hardin County, South Dakota, where Stan and Sue were found, and it was reported as being 76 million years old, but I don't think that's correct.
No. Yeah, T-Rex definitely was not around 76 million years ago. Maybe they inverted it and it's supposed to say 67 million years.
Possible. There's 2 large puncture holes in the skull. Unfortunately, the rest of the body eroded or just wasn't found, or I think eroded. But anyway, Maximus was expected to sell for 15 to 20 million US dollars.
Really?
Yeah. That's because of a lot of the sales recently have been pretty high, especially for Tyrannosaur fossils.
I guess, but those were like full skeletons, not just a head.
Well, Maximus sold for 6.1 million US dollars to an anonymous buyer, so much, much less than expected.
Still a lot, though.
Yeah.
I feel like if all you have is the skull, $6 million is still a good price to get. I mean, if you could only get one part of a T-Rex, the skull is probably the most valuable part. Although
Yep.
scientifically, I think the most valuable thing would probably be getting the arms because those are so rare.
Right.
But the skull is pretty cool.
In terms of display.
Yeah.
Yeah, it's just interesting hearing all this auction news.
Mm-hmm. I mean, it would be better if dinosaurs didn't cost millions of dollars because the museums would have more of a chance at getting them. Although there are museums that have tens of millions of dollars, like we saw the one T-Rex that ended up in Abu Dhabi.
Yeah. Or sometimes they can get funding.
It's true.
That's how Sue ended up in the Field Museum.
Yeah, very true. I think that was like $8 million, but that was also 25 years ago.
They've got a few other quick items, starting with an Edmontosaurus named Gary was airlifted from Red Deer River Valley in Alberta, Canada this summer. I like hearing the stories where they have to get helicopters involved.
Yeah, because they're just so remote. Like there's no road nearby, so it's like the only way out is a helicopter.
Just so heavy, yeah. The excavation was led by 2 university students, Annie McIntosh and Mark Powers. The fossils were first found by Gregory Funston in 2018, but it took a few years to collect. And that's because Gary is articulated and in this life position, as it's called, where it's crouched, not laying down.
Oh, wow. That's really cool.
Yeah, but it made Gary a lot harder to dig up.
Oh, for sure. Yeah. Especially if they're trying to keep it mostly in one block or just like a couple blocks.
Yeah.
Then you're working with really big pieces of rock.
Well, they planned to break the skeleton up so they could carry the fossils out themselves, but it just wasn't possible the way that Gary was positioned.
Cool. Yeah. I mean, it's always possible, but you might damage it.
Right.
So I guess they opted for the let's not damage it.
Yeah. But on the other hand, Gary weighed 900 pounds with the jackets.
Oh, that's actually way less than I expected. And it's a Edmontosaurus. I wonder if it's a juvenile because 900 pounds is not that much.
Yeah, and with the jackets too, so it's actually less. Gary is the smallest individual of its species of Edmontosaurus.
Okay, yeah, so it must, well, I guess it doesn't necessarily have to be a juvenile. It could just be a very small individual, but most likely it's a juvenile.
Yeah. So they were able to excavate or get Gary out because of the local community, and a helicopter airlifted Gary out. And so Gary is now at the lab. They're going to be comparing this specimen to other Edmontosaurus, and it'll be interesting to hear what they learned.
Yeah, the fact that it got preserved in a life position, as you called it, is so cool because when things are in like a more natural stance, you can do things like figure out more details about how they articulated, what kind of movements they could do. It potentially shows you basically like how far apart joints would spread when things were in different positions and like all sorts of details like that. It's really cool. It's also, at first I was thinking it was crouched and maybe it was like sitting on a nest or something, but if it's a juvenile, then it might end up being that it was just hiding.
Yeah.
Like it squatted down instinctively because something was coming, but it turned out to be like something that buried it.
Oh.
Am I being too? I mean, that's how things fossilize. They have to get buried.
But still,
Yeah. Especially in a lifelike pose, like you probably have to get buried pretty quickly for that to happen.
Yeah. Like the dinosaurs that were buried sleeping.
Yeah. Or the fighting dinosaurs. But those are the coolest ones too.
It's true. So a couple other quick news items. First, the Royal Saskatchewan Museum made it that you can get an AR model of Scotty the T-Rex.
Interesting. Do they have Scotty the T-Rex?
Yes. That's where Scotty is. So you can pick up a booklet at the museum and scan the QR code. This was part of Dinovember, so I'm not sure if you can still do it, but I hope you can because it sounds really cool. The AR model was developed by a local truck driver, Mark Towes, who taught himself how to make life-size AR models.
Oh, nice.
Yeah. And there's plans to make more AR models of Scotty as well as Triceratops and Edmontosaurus.
Yeah. I remember that, what was it, an Instagram filter that put dinosaurs like in your environment? And we were playing around with that a lot. It was really fun. It's really cool to see the scale of a dinosaur. The Instagram one wasn't the best for scale, but if you could get one that's pretty accurate for scale, it's just really cool to see like in my living room, how big would this thing, I mean, living room is a bad example because very few things would fit.
You'd see only a little part of it.
Maybe like standing next to my house. What head, which floor does the head of this dinosaur get up to?
Ooh.
Is it looking down the chimney? What's happening here? I really like that idea.
Yep. And then last, the Hongkong Post is issuing 6 dinosaur stamps.
Oh, cool.
Yeah. There's 7 species of dinosaurs featured. That includes T-Rex, Spinosaurus, Triceratops, Diplodocus, and Allosaurus.
Very nice.
Yeah, I know how much you like stamps.
I really do like stamps. We were using our T-Rex stamps to mail Christmas cards, and I was thinking like, oh no, I'm using all these T-Rex stamps. I like them so much.
We'll have to buy more sometime.
I don't think they sell them anymore. That's how stamps are. You can only get them. But we still have a couple sheets left. I might put one to the side and just keep it forever because I like them so much. I wonder if these will be like the T-Rex ones that were in the US a couple years ago, where some of them have holograms on them and things like that.
I couldn't tell from the picture.
Maybe we'll have to see if someone in Hong Kong can hook us up. You can see them up close.
And now on to our dinosaur of the day, Ostafrikasaurus, which was a request by Jaybird via our Patreon and Discord, so thanks. It was a theropod that lived in the late Jurassic in what is now Tanzania in the Tendaguru Formation. Only the teeth have been found.
Oh boy, one of these.
So no skull fossils have been found, but it's a Spinosaur based on the teeth. And because it's a Spinosaur, it probably had a long, narrow snout. It probably also had a long tail and a bulky body and walked on 2 legs. It's estimated to be about 28 feet or 8.4 meters long and weigh 1.15 tons. But obviously it's hard to estimate the size based on such fragmentary fossils.
Yes.
Now, these fossils were found between 1909 and 1912. And during those expeditions, 230 isolated theropod teeth were found.
That's a lot of teeth.
Yes. And one of them was assigned to Labrosaurus with a question mark, Stachowii, in 1920 by Werner Janensch, who tried to identify all of the theropod teeth by classifying them into 5 types in a monograph in 1925, which I can imagine was not the easiest to do.
Yeah.
In 2000, James Madsen and Samuel Wells referred the Labrosaurus with the question mark teeth to Ceratosaurus as just some kind of Ceratosaurus species.
Oh, that's surprising, because Ceratosaurus and Spinosaurus don't have that similar of teeth.
And Labrosaurus is now considered to be a synonym of Allosaurus, just FYI.
Okay, so that's different than Ostafrikasaurus.
No, these are the Ostafrikasaurus teeth. They started off as Labrosaurus with a question mark, then some kind of Ceratosaurus, and then in 2007, Denver Fowler suggested that these teeth were Spinosaurid teeth.
Oh, okay.
And Eric Buffetot in 2008 also suggested that they were Spinosaurid teeth. In 2011, Oliver Raoult found the Labrosaurus question mark Stachowii to be dubious as a dinosaur because there were no unique features, and then also referred the teeth found in the Tendaguru Formation as Ceratosaurus question mark Stachowii. So a lot going on with these teeth, which, again, there were 230 isolated theropod teeth found, so things got confusing.
But these weren't the only ones. These are just the ones you're talking about today.
Yes. So Ostafrikasaurus was named in 2012 by Eric Buffetot based on 2 teeth. One of the 2 teeth is the holotype. That holotype tooth is 1.8 inches or 46 millimeters long, and it's got this curved front edge with large serrations that are larger than other Spinosaur teeth.
Oh, okay. I can start to see where the confusion comes from.
Yeah, and then he tentatively referred a second tooth. Now, both teeth are curved in the front, but there are some differences in the ridges, which could be due to individual variation.
Or even just where in the mouth the tooth is.
Yeah, and the 2 teeth also came from different parts of the Tendaguru Formation, so that's why it's 2 specimens, 1 for each tooth. That's really hard to name dinosaurs based on teeth, but Eric said that theropod teeth, and in particular Spinosaurid teeth, can have unique enough features to name a dinosaur, and that's based on features such as the ornamentation on the teeth. And these teeth looked similar to the teeth of baryonyx. Ornamentation on the teeth have similarities to lots of different theropods, including Ceratosaurus and Coelophysis. A 2020 study of teeth from the Tendaguru Formation found Ostafrikasaurus to be a ceratosaurid.
Oh, we're back again.
Yes. Fowler, however, suggested that Ceratosaur and Spinosaur teeth were connected, but Buffetot didn't agree. And he described Ostafrikasaurus as an early Spinosaurid theropod.
I see. So if it's an early Spinosaurid, then it's similar to some more general theropods?
Yes.
Yeah, because I don't think of Spinosaurid teeth as being curved and serrated. They're more conical and pointy and fairly smooth.
Yes. Now, these teeth had strong ridges. Baryonyx and some close relatives, including Spinosaurid teeth found in Asia, also had strong ridges, and that's why the teeth are thought to be Spinosaurid. The type species is Ostafrikasaurus crassiceratus. The genus name comes from Ostafrika, which means German East Africa lizard. And the species name means thick and serrated and refers to the teeth. The enamel on the tooth is, quote, finely wrinkled. There's also large serrations on the teeth, and this helps show that Spinosaur teeth became more conical and less serrated as they evolved.
If they are, in fact, Spinosaur teeth.
Yeah. This may mean that earlier Spinosaurids had larger serrations on their teeth, and they evolved to have smoother teeth that were also more straight or less curved. So this is one of the oldest known Spinosaurid fossils. It helps show that Spinosaurids may have lived around the world before Pangaea broke up.
How old were these teeth?
About 150 million years?
Oh, that is old, especially for a Spinosaur.
Yes. So Eric, who named Ostafrikasaurus, suggested that Spinosaurids were widespread early on, based on Spinosaurids being found in Asia, and Asia probably was separated from the other continents in the late Jurassic and early Cretaceous. And of course, a lot of other Spinosaurs described are from the early Cretaceous, and that's much later than Ostafrikasaurus. In 2016, Alejandro Serrano Martinez and others described a possible Spinosaurid tooth found in Niger. And that tooth is probably from the middle Jurassic, about 14 million years earlier than Ostafrikasaurus, which would make that one the oldest known Spinosaurid fossil.
That is very old.
Yes. Ostafrikasaurus lived in a subtropical to tropical environment with dry and rainy seasons, and other dinosaurs that lived around the same time and place included sauropods such as Giraffatitan, stegosaurs such as Kentrosaurus, and other theropods such as abelisaurids and possibly Torvosaurus. And other animals that lived around the same time and place included pterosaurs, crocodiliforms, fish, and mammals.
And I'm going to quiz you on something about aquatic animals, but first, let's pause for a quick sponsor break. So with Hulscaraptor showing that non-avian dinosaurs transitioned from terrestrial to aquatic, how many times do you think that land-living animals have evolved into animals that spent most of their time in the water?
Oh my goodness.
Or to be more specific, how many times do you think tetrapods returned to the water?
I have no idea. I know about whales.
Mm-hmm. Wait, and you know about Natovenator?
Oh, yes. Okay. So there's 2.
Just throw out a number. What do you think? What feels right?
What feels right? 10.
This is in the right order of magnitude.
Okay.
So according to an interview about Natovenator in Live Science, that author said it has happened at least 30 times, which is a lot. That's 10 times as many times as vertebrates have evolved flight, because that's just the 3. You just have bats, pterosaurs, and dinosaurs. But it's still not an easy thing to do.
Nope.
These animals are called secondarily aquatic tetrapods. If you're wondering what the technical term for an animal that used to have ancestors living on land and then ended up in the water is, the reason they're called secondarily aquatic is because the ancestor to all tetrapods were aquatic. So those are the primary aquatic tetrapods. You know, those are basically fish, but, you know, fish with the lobe-finned fish that had arms and legs coming out of their fins eventually.
Mm-hmm.
And then some of those evolved to be terrestrial, and then the ones that return to the water are now secondarily aquatic. It's very similar to secondarily flightless birds, which is the technical term for something like an emu or an ostrich or a kiwi, because they're flightless birds that evolved from flying birds, not like dinosaurs, which hadn't evolved flight yet. It's easy to identify secondarily aquatic tetrapods. It's actually extremely easy Because they have lungs.
It's partly what makes them so strange.
Yes. Obviously, fish and these other creatures in the ocean had to evolve lungs in order to go on land. But then when they returned to the water, I don't think any of them evolved gills and lost their lungs. There might be one out there. Please tell me if there is one, because that would be fascinating. But I don't think it's happened. And evolving lungs to stay underwater doesn't really make any sense at all. So there isn't really any reason that an animal that is primarily aquatic, not secondarily aquatic, would have lungs. Because why, if you never left the water, why would you ever do that? But there is always an exception, like lungfish. It's a whole different story I don't want to get into.
Another day, perhaps.
Yeah, it's because of the specific way they live in places that dry out and stuff. But yeah. We already mentioned Hesperornis and Halscaraptorines, and then you just mentioned whales. But I want to go through some of the other secondarily aquatic tetrapods, just because I think it's a really interesting list, and connect them to what they evolved from, because there are a whole lot of pathways to go from water to land back to water.
Do tell.
So there are lots of quote-unquote swimming dinosaurs, according to, lots of children's books that lump a lot of Mesozoic things in with dinosaurs.
Oh, like plesiosaurs?
Exactly.
Mosasaurs?
So yeah, there's ichthyosaurs. We don't really know where they came from. There's sauropterygians, which include plesiosaurs, nothosaurs, and lots of others. Might be nothosaurs, I've heard that too. And then there's mosasaurs. Mosasaurs, we do know where they came from. They evolved from snake-like ancestors.
Oh yeah, that's weird.
And there's also sea snakes, which are another secondarily aquatic tetrapod. Weird that they're tetrapods, but because it's monophyletic, just because they lost all their limbs doesn't make them not tetrapods anymore. There's also sea turtles, which evolved from land-living turtles. Turtles always come up. There's quite a few modern reptiles, which are also largely aquatic. For example, there are crocodiles, which evolved from pretty dinosaur-looking pseudosuchians, which were on land. And then there are things like iguanas, which spend a lot of time foraging in the water for food. And then maybe most famously are the cetaceans. So that's dolphins and whales.
Oh, dolphins. Should have known.
Well, I mean, they're lumped in with whales. It might have, I'm not sure if they were separate events or just the one. But whales are really well documented in their return to water. It's an amazing story, maybe one of the coolest stories in all of evolution.
We saw that hall there's a natural history museum in Italy.
Yeah, it was in Tuscany. I think it was technically in Pisa or thereabouts. Yeah. Basically, you have these big wolf-like things that evolve into more and more aquatic fishing animals. Sort of like we were talking about maybe Spinosaurus kind of standing in the water, grabbing at fish, or like how grizzly bears do kind of thing. And then as they were hunting more and more fish, eventually their legs just started turning more and more into flipper-like things. And eventually they just turned into whales. And that's a reminder that all whales are carnivores.
Yep.
Something you don't think about because they seem so big and friendly, but they are hyper carnivores eating pretty much exclusively other animals.
Yeah, plankton is an animal.
It is, yeah. Plankton sounds small, but they can be pretty big. And we talked about that before too. They can be like 4-inch long shrimp, basically. As a bonus fun fact, hippos are the closest terrestrial relative to cetaceans.
I think I knew that.
You did?
Yeah.
That's such a weird fact.
Yes.
So hippos probably don't count as secondarily aquatic because they spend too much time on land. I think it's basically because they still have arms and legs and not flippers. But they're definitely semi-aquatic because they spend so much time. They just like stand on the bottom of the water and like they do this weird thing where they sort of like hop through the water without reaching the surface and all sorts of weird things. But yeah, they are closely related to whales, which seems so strange. Then another group are the Sirenians, which are fully aquatic. I'd never heard of that group before. It is included solely of dugongs and manatees.
Interesting.
The closest relatives to dugongs and manatees are elephants.
What?
So they probably evolved from some elephant-like creature. Manatee front flippers actually look exactly like a pancaked elephant foot, complete with the toenails.
What?
It's crazy. If you've never seen a manatee front flipper, look it up.
I guess I haven't.
It's really weird. And then I even just looked up like manatee and you get all these cartoony pictures. Everybody includes the little toenails on their front flippers. I think it's partly what makes them so adorable. They're really cool animals. And then last on my list are the pinnipeds. Those are seals, sea lions, and the walrus. They're the closest terrestrial relatives to them are the mustaloids. That's the group that includes skunks, raccoons, weasels, and the red panda.
Interesting.
Just the fact that the red panda is related to skunks and raccoons is weird to me.
Yep.
But mustaloids also include otters, and I was surprised those weren't considered aquatic. Most places don't consider them fully aquatic, but it's kind of weird because sea otters actually give birth in the water. They don't even return to land to give birth. And things like sea turtles, that's literally the only reason they ever come back to land for.
Yeah.
Whereas sea otters can give birth just out in the ocean.
What is the definition of semi-aquatic?
It's a mess.
Just keeps coming up more and more for me.
It does, yeah. But that does mean that seals, sea lions, and walrus evolved from something skunk or weasel-like. So that's pretty weird.
It is weird. And on that weird note, that wraps up this episode of I Know Dino. Thank you for listening. And it's the end of the year. Come join our community at patreon.com/iknowdino. And next week, in episode 422, we will be doing our best of 2022 episode. So be sure to stay tuned. Thanks again, and until next time.